So to do that, in order to loop, we're jumping ahead to chapter 7. So the way the loop is flow charted, this text doesn't show it, is something like this. In Unit 1 notes, there's a PowerPoint called Flowchart Cookbook. And it shows basically, these are known as flow control patterns. Why flow control? Because like if you poured water in the top, this would determine which way it flowed. This is like a dam or something that routes the water one way if it's set, another way if it's not. So this is just an if statement. If A is equal to B, then print, yay, A is equal to B. Else, well, there is no else. If A is not equal to B, we just do nothing and we fall through. So that's the simplest if. And of course you don't just put the word if there, you put the condition there. Now a lot of textbooks will show leaving off the word if. But since this diamond is used for more than one thing, since it's used for ifs, since it's used for whiles, and since it's used for fors, I prefer you to put the word if in there. However, if you want to say, hey, the textbooks don't show me that, you're free to leave it off. I think it's useful. So here's an if-else. An if-else in code, and I know we've seen it, looks like this. If A is equal to B, do something, print yay. Don't know why we're so excited about that. Else, and I'm not typing this even into Python, I'm not going to run it. Else drats. Okay. So the first if just looked like this. The first one in the cookbook. Maybe I should modify the cookbook so it actually has the code examples in it. If A is equal to B, print yay. That's it. It doesn't do anything else. It comes on it to do something else down here, blah, 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 blah. So when we look at our flowchart, our cookbook, the first one matches that one, the if statement. If this is true, do something. If it's not true, just fall through. Go to the next chunk of code. The second one here is an if-else structure. If something is true, do one thing. If it's not true, do something else. So instead of just falling straight through, there's another section of code here. Now, in flowcharting, there's no symbol for else. People want there to be a symbol for else, and I know I've said this, because there's a symbol for if. Why isn't there a symbol for else? Well, when you flowchart, typically you put yes and no, or true and false. But if you're missing that word else, if you're tempted to put it on your chart and you're trying to figure out a place to put it, you can replace that no with the word else. If, do something. Else, do something else. Then there's the if, else. And this is for things like, is the number too low? Do something. Else if the number too high? Do something. Else the number was perfect? Do something. So elifs let you chain if conditions together. And why do you do that? Because sometimes you want the if conditions to be mutually exclusive. You might be tempted to write a grade program like this. If score greater than equal to 90, I'm not going to even put the correct.
Did you start recording?
Yes, I did, but let me double check. Yes, excellent. Okay. Print A. Elif score is greater than or equal to 80. print B, elif, except we're going to make a programming mistake and not use elifs. Elif score is greater than or equal to 70, print C, else, and this is a really hard class, if you don't make above a 70, you fail. Not true. So there we go. That's our logic. Looks pretty good, but it's not. Let's see what's wrong with it. Exactly. If your score is above 90, it's going to print A and B and C. And there may be times when it'll print F when it shouldn't. I don't think that's true in this particular case. We got lucky. But since that else is only attached to this particular if and not the rest of them, it's conceivable that that could happen as well as that and that. Hey, maybe that was what was wrong with my email program. Anyways, so you want these to be mutually exclusive conditions. You want it to print either an A or a B or a C or an F, but not both of them. And that's what you use else ifs for. Other languages call them else ifs, at least the C-based languages and Java, but Python calls them elif. If you put else if in your flowcharts, that's cool. If you put else if in your pseudocode, that's cool, but if you put else if in your Python program, it won't compile. So there we go. That would make it work. The way you read this is if the score is greater than or equal to 90, print an A, and then it skips all the rest of the stuff and comes down here. Elif the score, if it's greater than 80, print that out. And if that happens, it runs all the way down here, skipping the rest. Same for that one. If it's greater than 70, it prints that and it skips everything else. And if none of those were true, then it prints the F. So that's what this flowchart is trying to indicate. If, yay, and then it runs to the end. Elif, yay, then it runs to the end. If none of those were true, okay, I'm going to do that. Now notice this looks a little bit different than you might want to have flowcharted it. And this would be correct if you didn't use elif, if you just use ifs. People get hooked on the idea that the if statement has to hook back up. And we did that with a circle, like that. And then it would come down here, and if that was true, then it would have to hook back up with a circle like that. That's if you don't use elifs. That's just if you use ifs. That's perfectly correct. And that's why it would print both an A and a B if you had above a 90. Because the loop went back here above the if. So when you're using elifs, the flowchart gets a little bit more complicated to draw. You can't just loop it back to above the thing, the following thing. Instead, you have to draw a line that goes underneath all of them. So it's more complicated to draw, but you get used to it. Is that easy enough to read, or do I need to lower the screen? Any opinions? Is it too blurry? Y'all shaking your head because it's easy enough to read? Okay. I'll lower this if I get anybody saying they want it lowered. Just let me know. Alrighty. So what kind of logic could you do with this? Well, we may have done this example before, but I'm not recalling that we did. I want a little program that tells me if if I can wear a short sleeve shirt outside. This is dumb, but we'll go with it. But I'm going to do it in pseudocode first. So I'm going to make a new file, but I'm not going to save it as Python. Or maybe I'll just make it a comment. To do a comment, you just do 3 quotes. 1, 2, 3, like that. and then you can type in a multi-line comment. If you like double quotes, you can do 3 double quotes. Okay, so the problem. If the temperature is above 120, it's too hot for a shirt at all. If the temperature is less than 40, it's too cold for just a shirt. In between those, it's okay to wear a short sleeve shirt. Should have said tank top. Easier to type. Yeah, I'm going to change it to tank top. It's okay to wear a tank top. And then the last condition is going to be it's too cold for just a tank top. So really, what we're doing here is we have something where our lower limit is 40, our upper limit is 120, and if I was going to define this precisely, I would need to let you know whether these bounds were inclusive or exclusive. I kind of let you know just there. I'm saying that if it's greater than 120, it's too hot. That implies that if it's 120, it's okay. And down here I say if the temperature is less than 40, it's too cold, which kind of implies that if it's 40 on the dot, it's not too cold. So my pseudocode. Input temperature. I'm going to change that to temp. I don't want to type the word temperature over and over. I'm not really digging the green text. I'm going to take the comment out. It makes it easier to read. Matter of fact, I'm just going to save this as a text file. So I'm going to call this tank.py. Nope, it's a text file, tank.txt. Okay, tank.text. So we input the temperature. Now I've already messed up my pseudocode. I probably griped at some of y'all for doing it. What should I do if this is the beginning of my pseudocode? Yeah, I need a start. Okay. Input the temp, and now we need some if statements. Let's handle this first case. If temperature greater than 120, now we don't need the colon. I'm not going to yell at you if you put the colon there because you're used to Python. However, if you hand this pseudocode to a C programmer, they're going to wonder why there's a colon there. If the temperature is greater than 120, we're going to output, and I don't care if you change that word output to print. Output, it's too hot for a shirt at all. Else, if, and since we're doing Python, I don't care if you change it to elif. Again, you're just kind of giving away your Python roots if you do it that way. Else if the temperature is less than 40. Now, there's more than one way to do these things. I could try to make an if statement that covers this middle clause. Or I could write one that rules out this bottom case and this bottom case and then do that as my default. I'll show you the difference between them, why I'm doing it this way. I'm going to call this condition A, just as a little parenthetical comment, and this condition B, and this one C. You don't have to do this. This is just going to be part of my lecture when I get back up there and draw. Okay, so if the temperature is less than 40, we're going to output it's too cold for just a tank top. And then lastly, else output it's perfect tank top weather. I don't really know about 41 degrees being perfect tank top, but okay. And now we're done. The problem didn't specify making it loop or, doing anything else, so that solves the problem as stated up here. Now, why did I do it that way? I'm going to show you another way of doing it. And in order to try to do that, I'm going to take some of these blank lines out. Okay, it could have looked like this. And I don't care if you type this in or not. Input temp, if temp is greater than 120, output too hot. Elif temperature is less than or equal to 120, and now see, we haven't really talked about ands, so the logic is already getting hinky here. And temperature is greater than or equal to 40. Output just right. Else output too cold. Now, once you teach somebody ands, they're tempted to solve this problem like that. I don't like this style of solution because we're having to put too much information here. The logic is too complicated. The advantage to it, or not the advantage, but why people tend to want to do this, is because the problem may be stated like this. If it's too hot, do one thing. If it's medium, do something else. If it's too low, do something else. And that matches this logic. It's too hot, it's medium, it's too low. So it matches that. But in order to match that, we had to do this really complex logic here. We had to use an AND statement. We had to specify that number twice. What if we decide that temperature being 120 is kind of not the right temperature and that we want to wear tank tops up to 140? I don't know where we live, Sahara or something like that. Then we'd have to change that number in both places, and if we forget to, then the logic's broken. So anyways, this is not a good way of handling a three-case situation to where you have a breakpoint and you want to handle, you know, if you have a limit there and you have a limit there and you want to do one of three things. This structure is better. So here's the first check. It does the too hot. Here's the second check. It does the too cold. And nope. That's the third check, really. It does too cold. And then the intermediate one. So what we're doing is we have a range, you know, of three different possibilities. We're ruling out too hot. Nope, it was too hot. Then we're ruling out too cold. Nope, it's too cold. That means it's just right. Goldilocks likes her porridge. You know, just right. There we go. That's why I recommend just using, avoid doing complex logic like ands, and avoid trying to specify both sides of the range in your middle statement. Just specify the upper end, that's the top end. Specify the lower end, that's the bottom. And then whatever the last case is the default, you know, if either one of those, if it wasn't too hot or too cold, if it wasn't too high or too low. Hope that makes sense. So what would be good now is to make this program loop. This is what it looks like if it doesn't loop. I'm just going to copy and paste it and write a version that loops. Yay, copy paste. Okay. So here's, I'm going to put a comment on the top one up here. Non-looping version. Then I'm going to copy all this stuff because a lot of the logic is the same. So I just highlight it all and I hit Control-C, or I go up to the Edit Copy menu, however you like to copy things. And I'm going to paste it, but in this case it is the looping version. The way the loop works is we need to set up a situation that'll cause it to loop, because it's like that if statement. If that first if isn't true, it won't do anything. If the first time you hit the while statement and the condition is false, it won't do anything. So we need to set up a condition that'll cause it to loop, but that we can then decide later is false. So I'm going to need a variable. Set repeat equal to yes. Now repeat is just a random variable name I chose. I could have called it Fred or continue or Barney or whatever. I just chose repeat because in my mind when I write the while statement, it's going to look good. While repeat equals yes, and I want to tab all this stuff over because it's underneath the while. It's all part of the while loop. So I need to highlight everything from the input to that last output and then tab it. You can hit the tab key, or you can go up to format indent. But we're not done. We want to ask the user if they wish to repeat. Output, do you wish to repeat? Input, repeat, like that. We can give them a clue. We want them to type in a yes to repeat. So I'm going to put a clue in that output statement. Do you wish to repeat y/n? At the very bottom, I like to indicate that the program is done. Or sometimes, I mean, you could put an input statement down there that says press enter to continue, so that, you know, if they ran it from by double clicking the icon rather than inside idle, they'll actually get a chance to look at the screen rather than have it close immediately as soon as it's done running. Output, done. Now this is not tabbed because this is not part of the while loop. When you flowchart a while loop, it looks like this. You do some stuff up here, blah, blah, blah. Then you have your diamond. If the case is true, then you do some stuff, blah, blah, blah. And then it hooks back up to the diamond. An if statement doesn't hook back up. But a while, the word loop implies that the control flows back to the while. And then it drops down, or you take it off to the side, and you do whatever is unindented. So you can see that this matches that, and all of that stuff is indented. And so then we have some final print statement, and we're done. Whatever. That's a really simplified version of this flowchart. Speaking of really simplified versions of flowcharts, we're going to draw it as a flowchart. We're doing the whole shebang. We're doing the pseudocode. We're doing the flowchart. I think in this case I am going to lower the screen just in case it makes it slightly easier to see. Because when I'm doing the flowchart, the text gets really tiny. All right, everybody good on this? This is not a program, it's just pseudocode. Pseudocode is like telling somebody to walk to Sooner Road and then turn left and walk to Walmart. Whereas if you were giving exact instructions to a robot, you would say, walk, 400 yards, turn 90 degrees to left, walk 300 yards. The difference between pseudocode is that it's loosey-goosey. We're trying to specify the logic, but we don't care if the syntax matches any specific programming language. And in fact, you don't really want it to. Okay, so fire up Lucidchart. Now, the very first time you went into Lucidchart, you followed that link I posted, but after you've created your account, you don't need to do that. Just go to lucidchart.com, type in your address, click Next, and enter your password. I don't care about working faster with add-ons. So new document. I suppose that we ought to spend a class getting used to Visio, because you may work at a job that wants to use Microsoft tools rather than online tools. But I like this one because the Mac users can use it, the Linux users can use it. Alrighty, all of our flowcharts have a start just like all of our pseudocode does. The eternal struggle, trying to get all of this on the screen at one time. Where's my idle? Alright, that should be enough to at least give me a clue as to what I'm doing. Okay. So, start. Set repeat equals to y. That's kind of mathy. It's not input output. So I'm going to put that in a process block. I could either add the word set or I could leave it off. Set repeat equal to y, capital Y. I'm going to shrink that. Then we have our while condition. While repeat equals y. Just a sec, I'm going to blather one more sentence and then I'll answer your question. Now use two equals when you're doing a comparison, either in an if statement or a while. You do one equal if you're assigning a value, like performing a calculation or initializing a variable. Had a question about that. Yes, sir?
I need some help.
Sure. So here's my while, and it's going to have two lines leading away from it. One line being the yes and one line being the no. I'm not going to worry about where the no goes right now, but I am going to do the yes. The yes is everything in our code that's indented underneath it. So we're going to have blocks for just about all of this stuff. And that's all going to be on the yes side, and then it's going to loop back to the while. And again, I am trying to condense space, which I shouldn't do. I think when I'm done with this, I may rearrange it a little bit. Input temp. Now, in a Python program, we'd have to convert it, float, and we'd have to print a message like, what is the temperature? I'm leaving all that stuff off because we're just diagramming the logic. Now we have our if statement. If temperature is greater than 120. I should have made it as too hot to go outside. And since it's really hot, I'm going to print a message. I'm going to shorten my message, just too hot for tank, dot, whatever. But I should have added the word output there, or print. In my flowcharts, for some reason, I like to put the word print rather than output. You can do either. Okay, it's really bugging me that I didn't line this stuff up vertically. I apologize. I'm going to fix that. That first while goes underneath the set repeat. However, I don't mind making my loop kind of jut up like that. Alrighty. Now we need to do an else, except I'm going to just leave this one as a dead end for now. The no line is going to come down to an elif. I need another diamond. Elif temperature less than 40. And if that's true, we're going to print too cold. And again, I'm just leaving that as a dead ends. Since we're dealing with else ifs, elifs, I don't draw the line back, I don't loop back immediately. Then we had one third case. We had a third case, which is a final else. So we have no, or like I said, if you want to use the word else, you can replace the word no with else. I'm just going to put no slash else to remind us that I could put the word else there. My last diamond. No, I don't have a diamond anymore. I'm just going to print just right. Print, it's okay to wear a tank top. Bless you. Alright, so there's our flowchart as is, but it's got serious problems. The biggest problem is that we have dead ends. We have to resolve those. If you have dead ends on if statements, you need to just draw a line from the dead end back to the next statement after the if. But we're doing if, elif, so we've got to put a circle underneath the whole shebang. I'm going to have to scroll down a little bit, tack on a circle there. That's a huge circle. It does not need to be that big, and it doesn't need a letter in it. And all of these things need to loop back to that circle, which can be a real pain to figure out how to do. So I'm going to draw a line off to the side rather than coming straight down for that shape. And then I'm just going to draw one coming straight down from that one. If you have a whole bunch of if, elifs, it gets really annoying to do. But I'm not going to make you do anything that has like more than 3 cases. All right, now that we're done with our if, elifs, I'm going to flip back to the code just for a second. What did it do after our if, elifs, elifs? We said, do you wish to repeat? And then we asked them for repeat. So underneath that circle, we need another print statement, or at least an input block. Getting a little crowded. I'm going to zoom out once. The way I zoomed out was with the control key and the mouse wheel. So I'm going to tack on a print. Do you wish to repeat? And then I'm going to do an input repeat. And that's the last thing in our loop. If I go back and I look at my code, that was the last thing of the indented code. When I hit the last thing in my indented code, I need to draw a line back up to that while. Like that. I wish I could get rid of this try the beta thing. This whole line here is just taking up space. Oh well. I think you're raising your hand or stretching? Okay, okay, cool. All right, we're just about done. What's left? What have we not covered in our code? Yeah, we just haven't done an output done. So I need a no line coming off this repeat. I could either draw it straight down or off to the side, whatever. Output done or print done. I've been using the word print, haven't I? So I guess I'm going to put the word print. And then just draw a stop. All right. I know I didn't quite get it all on one page, but it's pretty close. Now when you're drawing it, you absolutely don't need to try to fit it all on one screen. I think I'll show you how I would arrange this if that was not my concern. I'm going to scroll this off real quick, but I'll come back to it. Okay. What I like to do, if I can, if I have room, is line things up like this, so that it looks like the pseudocode. And then this stuff, after the while statement, would be down at the very bottom. Okay, I have to zoom out for you to see the whole structure. That looks an awful lot like our pseudocode did, right? The structure of it. Here's this, repeat equals yes, here's a while, there's our if statements, our else. The only thing that's different is that this else stuff isn't indented like the rest, but that's just kind of a quirk of flow charting. And then we stopped indenting and we had our output. That's how I would draw it if space was not a concern. However, since we all draw at different speeds, I don't want to just assume that we can all scroll up and down at the same rate. So, Kanye West wrote my program. All right, even though I haven't typed in Python code up here, I want to talk about the homework. So if you're still working on the Python, take a break. So this is actually 3 homework assignments. Sounds hard, but it's almost exactly what we did today. So don't stress about it. I mean, this is like a quick way to earn 300 points just for repeating what we did today. So, the homework: write the pseudocode for a program that determines if a person is too young or too old to enlist in the Coast Guard. The age range for enlistees in the Coast Guard is 17 to 32. If you're 17, you have to have parents' permission. If you're more than 29, you have to be attending one of their special schools. So if you're 16, you're too young. If you're 33, you're too old. So here's how the program should look once written. What is the person's age? 9. They are too young. Then you run the program again. What is the person's age? 49. They are too old. Then you run the program once more. What is the person's age? 20. They are perfect to join the Coast Guard. Now, we made our program loop. So go ahead and do that. Extra credit if you make the program loop. If making it loop totally stymies you, you'll still get, a good grade on it, but you get extra if you make it loop. You ought to be able to do that. We covered that in class. So homework 4 is do the pseudocode. Homework 5 is to draw a flowchart for it. If you like doing flowcharts first, you can. Just take a look at what you did today, and it'll guide you. It is your sensei, your Jedi master. Homework 6, write a Python program. So everything we did today, just put pseudocode in homework 4, put the flowchart in homework 5, put the Python code in homework 6, and you've earned as much 300 points, toward your final grade. So, hope that makes sense. Some of y'all are well ahead of me. That's totally cool. If you don't want to hang out for this, that's totally cool. So what's the first thing in my flowchart or my pseudocode? Was something like set repeat equals yes. Was that correct? Set is only for pseudocode, not for Python. I kind of wish that it was in there and then would just ignore it, but oh well. So repeat is equal to y. Or if you like lowercase y's, you can make it a lowercase y. Then we have a while loop. While repeat is equal to y, nope, it needs to be in quotes because it's something the user typed in. Now every time you start indenting, you have to have a colon before it. So you got to put a colon after that while statement before you hit enter. And you didn't do that on the pseudocode, so why should you know to do it on the Python? Well, now you know. Now we need to ask them what the temperature is. So what you had is this line, repeat is equal to y or n. You were trying to define limits for it. We don't really have a way to do that in Python, so just initialize it to a value. So print, what is the temperature? We got to get the temperature. I forgot my close parentheses. So easy to make typos. So temp is equal to input, and then we got to convert it to a number, either an int or a float. I like floats because people may want to say it's 98.6 degrees rather than just 98 or 99. Okay, so what some people were struggling with was this process. They either just want to type input, or they want to make it look like pseudocode where you say input temp. And I'm sorry that the pseudocode doesn't match the Python. We have to follow the Python syntax. So temp is equal to input, parentheses, and then temp is equal to float, parentheses, temp. Now we have our temperature. We can do some if statements on it. If temperature is greater than, what, remind me the upper range.
120.
Yeah, for a second I started thinking about the Coast Guard program. Sorry, my brain froze. If it's greater than 120, we're going to print a message. Too hot for sure. Now notice because I tabbed, I needed a colon before it. So if statements, just like while statements and elif statements and else statements, need a colon at the end of it. Do you need these parentheses? No, I'm always typing them. They're not necessary. If you like the way they look, go for it. But they're just unnecessary in this language, and anything unnecessary is a typo waiting to happen. Elif temp is less than 40, colon, print, too cold for tank tops. And now we only have one more choice, so we don't need an elif, we just need an else. Print, perfect weather for tanks. Now, is that the end of my while loop, or was there something else? Yeah, we need to ask them if they're going to repeat. So print, do you wish to repeat? Y/n. Close quote, close parentheses. And then repeat is equal to input. Now, why am I not going to use that int or float on repeat? I had to do it when I was inputting the temperature. Why don't I do that down here on the repeat statement? It's not a number. Yeah, so it's already good. It's a string. And when you have a string, the computer thinks of it as being something that's surrounded by quotes. All right, that's the end of our while. So I'm going to back tab, just hit backspace, to print my done message. And if you feel like it, you could put a final input statement that would just keep the screen open even if you ran it by double-clicking the icon. Just like that. You don't need to store its return value in a variable because we're just waiting for them to hit enter. Now that wasn't on our flowchart. It'd be totally correct if I left that off. The only reason I add that is if you download your script and then double-click it, it's not going to launch idle. It's just going to run it in the Python shell, and it'll close the window before you get to sit there and enjoy the results. I could tell the user what they need to do. I could say done, period, press enter to finish, something like that. All of that is superfluous. We could have just done print done, which is what the flowchart showed. Where did I learn to speak? Alrighty. That's our program. Let me test it, make sure it works. If you've got it working, then you can call it a day. Looks like we're out of time anyways. Okay.